So in monitoring considerations are the first one. Power quality monitoring is the process of gathering, analyzing and interpreting raw measurement data into useful information. So we gather the information, we analyze that information and we interpreting that information to useful information. Monitoring to characterize system performance, monitoring to characterize specific problem, monitoring as a part of an enhanced power quality service, monitoring as a part of predictive or just-in-time maintenance. So monitoring as a part of facility site survey. So nature of the problem. So where we need to monitor is the first important, where we need to monitor. For that one we do the site survey. Nature of the problem: data loss, nuisance trips, component failure, control system malfunctions, etc. That is the nature of problems. Second one, characteristics of sensitive equipment experiencing problems. That's all. Equipment design information or at least application guide information. The time at which problems occur. Coincident problem are known as operating. Example, capacitor switching that occur at the same time. Possible sources of power quality variation within the facility. That is a motor starting, capacitor switching. Power electronic equipment operation, arcing equipment, etc. Existing power conditioning equipment being used. These are the monitoring as a part of facility site survey. Seventh one also, electrical system data. The data connected from one line diagram, transformer size and impedances. Load information, capacitor information, cable data, etc. So these all are the electrical system data. So while doing the monitoring, the site survey is important. Monitoring as a part of facility site survey. Determine what to monitor. Choosing monitoring locations. Options for permanent power quality monitoring equipment. Disturbance monitor connections. Setting monitor thresholds. Quantities and duration to measure, finding the source of a disturbance. These are the steps. So please see this diagram. This diagram gives illustration of system power quality monitoring concept with monitoring at the substation and selected customer location. So this is a transmission system. So that here there is a generating system. After the generating system there is a transmission system. In transmission system we increase the voltage levels for reducing the losses. After finishing the transmission, nearer the load center have a distribution substations. So nearer the substation, so we must do the monitoring in substation. That is the first aspect. We do the monitoring in substation. So after monitoring is finished in substation, that must data is collection. Data collection is very important. So this will stored in monitoring database. So monitoring database. So again we discuss substation monitoring system. So in substation monitoring we collect the data. This data is stored in monitoring database. So next one is, after distribution substation there is a number of substation line, that is the distribution lines, number of distribution lines. The distribution lines is connected in factories or consumers, etc. So this is a customer monitoring system in factories. So factories also we collect the data. Customers also we collecting the data. We collecting the data at each interval. That interval will be there is a of every 10 minutes or every 5 minutes, every 1 hour. We set the data. So every time we collecting that, every time period or every instantaneous time we collect the data continuously, collecting the data continuously. So after the data collection we do the monitoring, we stored in the data in monitoring database. These are the local networks. So after finishing the stored in databases, we analyze the data, we analyze. So this is a local network, this is a corporate internet, power quality, reliable performance and data analysis. So once the storing of data finish, we analyze that data. So power quality monitoring techniques, how to monitor different problems, how to monitor. We discuss power quality monitoring techniques. So if there is a flicker and interpretations in a data, in a flickers or interruptions in a data. So flicker is a on and off, the light on and off, the frequency causes on and off in a load. Interruption is a continuous absence of voltage or current on particular time. So this can be analyzed by using Hilbert transform HT. We call it as Hilbert transform HT, or total energy operator, or high resolution technique. We using these three techniques for analyzing flicker and interruptions. Second one is harmonics and total harmonic distortions. So the harmonics and THD are analyzed by using fast Fourier transforms, singular value decomposition, lab view, Kalman filtering KF. So if there is a voltage sag or swells, that can be analyzed by using adaptive linear combiner. So by using these techniques, we analyze the data. So permanent power quality monitoring equipment. So what are the equipments we use for monitoring? So first one is digital fault recorder. So the name indicates that records the faults. Normally the faults are symmetrical faults and unsymmetrical faults. In symmetrical faults, so there is a triple line or triple line to ground faults. Unsymmetrical faults, line to ground, double line faults are unsymmetrical faults. So second one is smart relays and other IEDs. Smart relays is a sensing of faults. Relay senses the faults. Third one is voltage recorders. Every time we must record the voltage, because which is present in a system, which disturbance is present in a system, that is recorded the voltage recorders. If the reference voltage is 230 volts, so every time we monitor that one, that comes 230 or not. So beyond 230 or below 230, that will records by using voltage recorders. Fourth one, in-plant power monitors. Fifth one, special purpose power quality monitors. So special purpose power quality means that will be recorded both voltage and current. Special purpose means that will records voltage data and also current data. Sixth one is revenue meter, is also similar manner of special purpose meter that will records voltage and current data at every time or every instant of time. So these are the equipments used for measuring the data. Please observe this: measuring devices. By using these devices, we measure the voltages or currents or frequency. Different measurements. By using these devices, we can measure difference. So every time we measure that one, we can analyze the data.